Let's dive right into this explainer and discover exactly how you can transition your AI agent from a fragile, unpredictable prototype into a rock-solid, production-ready product. Look, you've probably been in this exact situation before. You're watching your AI agent perform absolutely flawlessly in a controlled demo. It's an exciting moment, right? But then you deploy it into the real world and its behavior just quietly begins to drift. Today, we're unpacking exactly why that happens and, more importantly, how you can build the critical evaluation infrastructure to stop it in its tracks. So, here is our agenda for the explainer today. We'll start with number 1, the production environment trap. Then 2, rethinking agent evaluation. 3, observability and step-level tracing. 4, golden data sets and governance. 5, the 3-level evaluation stack. And finally, 6, engineering AI reliability. Moving to Section 1, the production environment trap. Let's start by looking at why these agents fail in the real world. 91.4%. That is a staggering failure rate for OpenAI's GPT-4o in live environments. And by the way, Amazon's Nova Pro V1, it failed 98.3% of Office tasks. This just goes to show that navigating real, live environments is exactly where agents break down. See, an AI agent's core strength is actually its non-deterministic nature. It operates through probabilistic reasoning rather than fixed, rigid pathways. And while that flexibility is absolutely crucial for handling new and novel situations, without clear behavioral measurement, that navigation gets really unreliable really fast. What's really fascinating here is that these failures, they aren't about the model's fundamental intelligence. Instead, we are looking at a subtle, creeping behavioral drift. Your retrieval process might just start pulling slightly off-topic context, or maybe tool selection becomes a bit hesitant, or you start seeing these quiet, logical gaps in its chain of thought reasoning. It's a gradual decline in precision, and because it's so gradual, it's incredibly difficult to catch with standard monitoring alone. Ultimately, this slowly chips away at user trust. They start second-guessing the outputs, creating manual workarounds, and eventually, they just abandon the tool altogether. That brings us to Section 2, rethinking agent evaluation. We really need a total paradigm shift here. Many teams try to solve these behavioral drift problems by just tweaking prompts. But a prompt merely sets the initial direction, right? It can't govern the countless micro-decisions the agent makes during execution. This comparison perfectly illustrates the difference we need to embrace. Traditional testing, your standard QA, validates static code. It's a simple pass or fail gate. But behavioral evaluation, that governs probabilistic reasoning in novel, unexpected situations. It doesn't just ask if the code compiles or works. It asks, did the agent act appropriately given the practically infinite number of possible inputs? It shifts evaluation from a static, one-time snapshot into an ongoing, continuous control mechanism. I love this analogy. A powerful model is an engine without a steering wheel. A well-designed LLM evaluation framework acts as that steering wheel. It ensures that raw, unbridled capability actually translates into trustworthy behavior over time. The true reliability of your agent is defined by the strength of its evaluation system, not just the underlying model you choose. Your evals literally have to function as a persistent pulse check on behavior, running right alongside your live production traffic. All right, Section 3, observability and step-level tracing, because you absolutely cannot govern a system that you cannot see. Your evaluation system is only as good as the data feeding it, so step-level tracing is non-negotiable. To evaluate effectively, you need granular, deeply detailed visibility into every single micro-decision the agent makes during a complex exchange. If you're just looking at basic input-output logs, you are basically just guessing at the agent's true behavior. You have to mandate step-level tracing. You need to see the exact context it pulled from your knowledge base, every single API call it made to a tool, and the precise logic behind its routing decisions. And this rich telemetry, it is incredibly powerful. Production traces are literally your most valuable data set. By clustering these recorded successes and failures, your team can start solving entire categories of behavioral issues instead of just plain whack-a-mole with random, one-off outages. These traces become a continuous living record of real-world performance. They let you proactively manage quality, like noticing if a specific tool's usage pattern is getting weird before the user even realizes there's a problem. Section 4, golden data sets and governance. Let's talk about setting standards and ownership. When your system's behavior is probabilistic, traditional engineering ownership models kind of start to fracture. Someone has to be accountable for how the system acts, not just how it runs. This is usually championed by an AI product manager, and their absolute best tool is the golden dataset. Think of this as the institutional behavioral memory for your entire system. It isn't a static test suite, it's a living, breathing collection. For example, the Microsoft Copilot team actually recommends starting with about 150 expertly curated question-answer pairs for complex domains and having them rigorously validated by human labelers. Now, why is this so crucial? Because this dataset prevents that incredibly frustrating scenario where you push a new update and accidentally break an old, perfectly working capability. Every evaluation run against this golden dataset acts as a massive regression safety net. When you discover a brand new failure mode in production, you analyze it, you fix it, and then you codify that new test case straight into your golden dataset. That means that specific failure can never happen again without sounding the alarm. Your system literally grows more robust with every single issue it encounters. Okay, moving to Section 5, the 3-level evaluation stock. This is how we actually put this into practice to eliminate blind spots. Because relying on just one evaluation method is a massive risk. Consider this. LLM judge agreement rates can drop to somewhere between 64 and 68% on expert tasks, like in law or medicine. That is well below human inter-expert baselines. So if you're only relying on one method, you're flying blind. You need layered defenses to catch what a single method is guaranteed to miss. And this seamlessly visualizes that defense stack. Level 1 is your deterministic unit evals. These are the fast, cheap, automated tests that verify the basic mechanics, like, did it call the correct API? Then Level 2 introduces human-aligned LLM judges. This is where you use a more powerful LLM to evaluate complex, subjective outputs against human-defined rubrics to ensure safety and alignment. And finally, Level 3 is real user experiments. This measures holistic success through A/B testing or canary deployments. It creates this perfect feedback loop. Insights from real users refine your Level 2 rubrics, and failures caught anywhere in the system seed brand new Level 1 deterministic tests. And our final section, number 6, engineering AI reliability. Let's recap how we turn AI agent development from an unpredictable craft into a disciplined, repeatable engineering process. Here is your checklist. Remember, failures in the wild are behavioral. They're silent drifts in reasoning or retrieval, not necessarily the model failing. Because of this, tracing deep reasoning chains is absolutely mandatory. You can't evaluate what you can't observe. Make sure an AI product manager specifically owns behavioral quality. Curate that golden data set to act as your system's evolving memory. And lastly, implement that 3-level evaluation stack so you can replace random prompt tuning with real evidence-based iteration. I want to leave you with this thought to mull over. A correct answer that comes from a flawed process, that is simply a failure waiting to happen. So ask yourself, is your AI agent truly reliable, or is it just getting lucky? True reliability requires evaluating the invisible reasoning behind the result, not just checking the final output. If you can govern the micro decisions your agent makes using this evidence-based framework, you won't just have a really cool demo, you'll have an enterprise-grade agent that is built to last. Thanks so much for exploring this explainer with me today.